So the question
All
is,
right.
how many people would it take to get people to work?
All right, excellent. Thank you very much. So first off, I'll say this was my 28th CES that I attended. And I have holes in my shoes to prove it. So a couple of housekeeping things first. Everything I'm saying is from me. So doesn't express the opinions of the IEEE or my employer. So if you don't like what you hear, it's my fault, nobody else's. My presentation isn't an endorsement of any company's particular product. Consult your tax advisor before investing. I mostly covered image capture devices. There's a lot of stuff there, and there's a lot of things I'd love to share with you that were just super exciting that I saw there, but we have limited time. The slides will be posted online, so you don't have to ask that question. We have a lot of material to cover tonight. Tom and I were talking just beforehand, and I'm estimating that I have to cover about 16,000 square feet per minute for my portion of the presentation. So save your questions to the end, and you can look for us here or somewhere in the back. All right. There we go. All right, so welcome to CES. 180,000 people. If you haven't been there before, it's a lot of people in a small space. There's lines for everything. One of my favorite lunches that I get here is the $16 for 2 hot dogs and French fries. For the older people in the room, they can relate that to what that used to cost once upon a time. And then this is the former mayor of Las Vegas who came and opened the IEEE Consumer Electronics Conference. ICCE. And it's the 15-year anniversary of the Consumer Electronics show itself. So pretty cool. It's amazing that whatever that guy went through in his life, he's still up there standing and sharp as a tack and articulate. He probably some powerful things. All right, first off, very quick intro. Let's talk about AR, VR. What is AR? What is VR? I'll give you just a few seconds on it. AR is augmented reality. Just means that you can see whatever's in front of you, and then there's some stuff to help you get more information about what it is that you may be looking at. VR is virtual reality. When you have this on, you can't do anything else. You can't walk around. You have to be careful you don't fall over. AR takes less hardware to do because you're putting an image somewhere in the field of view. VR takes a lot of hardware to do it. And badly done VR can make you sick because it's disrupting your whole human control systems. So when you're watching VR and you're moving around in a certain way, like that. And you're expecting things in the world to behave consistent with the way they do in your normal life, and they don't, it can make you sick. Or, if you're walking through the air, on top of a skyscraper, there's nothing underneath you, your body's control system kicks in and goes, okay, you're going to die in a minute. But you're not, because you're in a VR world. So there was actually a discussion at the ICCE about necessary things to bridge the gap into VR games and kind of the do's and don'ts. All right, covering the capture devices. Go through spherical. So the first thing I did in terms of research and observation that I've done the last couple of years are what's called many sensor spherical cameras. Spherical camera essentially covers a whole entire spherical view of your surroundings. Up, down, left, right. A complete circular capture. And in the earlier days, go back a few years ago, these types of cameras would use many sensors. You can see here it says 8 full HD sensors in that product. There's another one, multiple sensors. can see them here, they're all pointing in different directions. You capture everything, and then during the playback experience, if you're looking on a browser, you can see this on YouTube now. They'll have full spherical video, and you can move around. You can watch motorcycle races, and you don't want to see what's in front of you, you want to see what's behind you, or you want to look down the road. That's all there. As I said, it's more than 2 sensors. There's a process called stitching. And stitching is where you have to take the images from multiple sensors and essentially sew them together at the seams. It's a very, very hard process to do. I'm going into the details of all of it. Some of these cameras will do the stitching inside the camera itself and present it as a full spherical image. And other cameras will require you to post-process it. And in some cases, it can take more than 12 hours for every hour of video to accurately stitch it together. If you're using more than 2 sensors in a camera, you get into more exotic areas of silicon processing. There's a lot of system-on-chip devices that were designed for 2 input streams, which is consistent with how the cell phone industry has evolved with front and rear-facing cameras. So they'll have dual image pipes. They're adding things to do some level of in-camera stitching now. Important point, this is why I'm not going to go into a lot of detail on this. These are not, probably will never be consumer price. A lot of them, because they're using multiple sensors and capture very high resolution multiple images, and it's beyond what's realistic in consumer products. This is an exploding market for the VR industry to capture content. And there's a lot of stuff that's being posted on the internet. There are things like national parks and art museums and things like that. It's really exciting and spectacular things to watch. The number of companies in the space is starting to dwindle. We have the professional companies moving up more, and they're going to other shows like NAB, and then the consumer products are all moving towards the dual sensors, which leads me right into my next slide. So this was the second year for a couple of big companies, Nikon and Ricoh in particular, showing products that they have that are dual sensor spherical cameras. A lot of things with varying quality. Again, some of them can do high quality stitching. Most of them do what's called a dirty stitch. And it's enough that like, if you want to post something on social networking and you just want to get a concept of what it is that you're looking at, you can get a full stitch image out of it. Spatial audio is like another interesting area that's starting to evolve for these products because, if you take something like me speaking in this room, if you're looking at me, you expect to hear my voice in the forefront. But if you decide you want to look at the back of the room, it would make more sense that the sound that goes with that, when you're looking in that direction, sounds muffled, if your head's turned and you're not listening. So that's evolving. And this is a big deal here. Who knows what UGC is? User-generated content. This is the best thing for the entertainment industry because it's free. So it comes from the users. So this is really critical for a lot of VR stuff. And this is where you're starting to see things posted, like people posting spherical travel content and museum content and things like that. Just go through like very quickly all the real specs. Just to say that Kodak, so far, Kodak and Samsung look like they've got products with the best capture resolutions and capabilities on the market right now. It's kind of nice to see Kodak coming back into this space, who was such a pioneering company in this industry. Nikon still is kind of a first generation product in terms of its imaging capabilities, but a company with tremendous capabilities internally, so keep an eye on them for things in the future. Quickly moving on, another area that's kind of interesting that's evolving is spherical phone cameras. They're add-ons to existing phones. It's lower quality video. They're primarily used for social media, Instagram, Facebook. This category is going to go away, and I would expect, at least by next year, 2 years at the latest, that you'll see companies like Apple and Samsung will come out with spherical capture phones because they already have 2 image sensors in them, for forward and rear-facing cameras, and all they have to do is like shift the position just a little bit to align them a little better for spherical capture. So sadly, there's some companies, with some well-engineered products, but I feel pretty confident in saying that this is probably going to fade away quick. The company that you go to work every day is a major player in this market, and I had written something else up here, and then I thought it would be better to just say that it's quickly becoming a mature market. There's some good things coming out, but the excitement is moving on to other newer things for the early adopters. Everybody's doing 4K video, so if you don't have a 4K TV, now's the time to run home and tell your wife or your husband, if they're both genders here, that you need to buy a 4K TV. A lot less copycat companies. Some interesting features that are coming out, things like in-camera editing, so you can edit the pieces you want and just upload those. And then object recognition. So you'll be able to do pretty soon searches for things, like where's the video of me riding my bike or surfing or my mother-in-law or something like that. That'll help manage all the content because these products generate a ton of content. And Tom will talk about that later. Drones, was it last year? It was like all of the show. You couldn't walk anywhere without a truck drone or something that was drone related. This is the second year that had a whole dedicated hall for drones. It's starting to stabilize a little bit with all the companies in the drone space. It's still dominated by DJI, who's doing some really well-engineered, well-executed drone products. Collision avoidance, as you might imagine, is a big thing for drones, and starting to see product come out with this capability. Collision avoidance and follow me are also kind of lead into the same underlying technologies for computer vision, which is what our very generous sponsor here that provides this meeting has been making fantastic developments in. Collision avoidance for obvious reasons. You go out and buy a nice expensive drone and then fly into a tree or a telephone pole inside your house. There's lots of really fantastic videos you can watch that are very sad to see. Somebody unwrapping their brand new drone and full speed into the side of something on the wall.
Tree, several trees.
Yeah. And then there's all kinds of other applications that come out for drones, that we're starting to see, like early responders are using them to find things, to find people, to cover events. There was a company there, Airbus, European military company. They make there was a very polite term they used. It was a drone disabler, I think was the term that they used. Where you can put these around stadiums and they say, disables the drones. And they didn't elaborate how, but they have this vision of they're exploding air or something like that. And there's a lot of great things that are coming out of the auto industry because there's a lot of good investment that's being done in automotive electronics, which are indirectly and sometimes directly benefiting the drone industry. This one is really exciting. I think I talked about this maybe 2 years ago, LiDAR. LiDAR is really expensive right now to implement. There's people working on silicon and MEMS-based LiDAR. But when you talk about LiDAR for for things like a drone with a collision avoidance, you have a more narrow area that you're looking to manage, compared to the full rotating LiDARs like you see on the Google cars.
So what is LiDAR?
LiDAR is laser distance sensing. You shoot out a light beam and then you measure the time of flight coming back. It's been around, I don't know, multiple decades. Came out of the military industry. Now these things are evolving down to silicon implementations. This one, what I meant to say here is global shutter sensors. So today's CMOS image sensors, most of them are raster based. So they scan across starting at the top left and they capture all the pixels, shift them out, and go down to the bottom. For things that you're doing for collision avoidance, you want something called a global stack shutter. Where you take a picture, you look at the picture, because you can't, by the time you get from the top left to the bottom right, things kind of changed in the scene. And something's there that you didn't know before. It's very expensive to implement global shutter, so there's a lot of companies working on more cost-effective ways to do that. Auto industry needs this as well. So this will come down into consumer products. There's a company who made a LiDAR sensor for a bicycle. So if you're riding into a wall, this thing will tell you that there's an obstacle coming up. Maybe if you're not seeing the wall while you're riding the bike, there's other issues. We'll go into that. This is a whole new area I had never seen before. Underwater cameras, and I'm not talking about a GoPro with a little plastic cover on it. This thing in here, this is a little tethered submarine with a 4K underwater camera. I mean, this is, it was amazing. Here's another one here. Here's another one. You can't see here. They had an inflatable swimming pool here. Driving a little camera around here. Here's another one. You can see these propellers here running this thing. It's like, who would have thought? I'm not sure who the consumer is for this, but again, these are well-engineered products. They're tethered, because obviously you can't use wireless control while your submarine's running under the water. You have to run it at 30 kilohertz wireless link. Probably fast enough for what you need. You can discover your inner Jacques Cousteau, I guess, if you want to make documentaries. But more realistically, it may well serve a market for which I have no understanding of whatsoever. And if you think about other parts of the world, Hong Kong, Philippines, Malaysia, where they're surrounded by water, these things could be very beneficial for, besides hobby, like, underwater inspection. If you live on a boat, you want to look about what's going underneath, you want to find fish. There's probably all kinds of things that I am completely clueless about. But we're here at the Consumer Electronics Show looking for customers, so they must be under $1,000 when we're told. All right, I'm going to go on to another subject here. Things that are enablers. And these are things where you start to see in the corners of the show companies that may be not so exciting to the mainstream CES attendee, but for me are very exciting because these are kind of early warning indicators. Maybe warning isn't the right word. They're early indicators of capabilities that are going to be coming out at reasonable cost that will make their way into products that we haven't thought about yet. Because there's somebody, as I mentioned, the global shutter CMOS sensor. This is really big. MEMS LiDAR. The way LiDAR works is it has to scan this laser beam around to look for things. When you can do something like this instead of a motor, you have a little microscopic MEMS mirror. That makes something that used to be this big, to be this big. And it also makes it practical to put it into small things. There's a company that has a smart cane. And again, you can put LiDAR in it, so that you know that when you're walking into the wall, the thing warns you that there's an obstacle coming ahead. But joking aside, for somebody who's blind, that could be, you know, open up a whole new level of abilities for them that didn't exist before. Yeah, again, like the low-cost LiDAR, how many bus and train accidents have we had in the last year? You know, put a LiDAR or even a radar sensor. And there's a lot of radar developments that I didn't cover in my presentation here that's being done for collision avoidance for cars. So if you can go buy a new Honda that has radar built into the grille, it seems like, you know, maybe all the Greyhound buses should have this too. So lots of things that are driving the cost down. Silicon gyros. Every drone that's manufactured has a gyro. Well, it's not a true gyroscope. It has a facsimile of a gyroscope in it. And that was one of the technologies that made the drone market possible, because motors and motor drivers have existed for a long time. Radio control has existed for a long time. It's the gyro and the stability of the control system that made it possible. Today, most gyros are approximated. We use an IMU, inertial moment unit, that gives you gyroscopic-like information, but it's not a true gyroscope. So there's people working on stuff for MEMS gyros. 3D depth sensing with imagers, that's another kind of cool area. You can walk in the store, you know, walk around like this, tell you what your shirt size is, because you just measure your body. Google's done a pretty good job of mapping the outside world. They really want to map the inside world, like malls and hotels and museums. And this is another way that they can scan to get interior data. VR. Everybody knows what VR is. It takes a lot of specialty silicon to make good VR goggles. Again, you're starting to see stuff. You know, there was a little display and a little table from what people might think is kind of a growing company. And you see that and you go, okay, that's something that's going to start popping up in a lot of VR products, because they need very small, high-resolution displays, completely different than what's been required for LCD displays in the past. And there's always been small size, small resolution, big size, big resolution. And we need small size or big resolution. Pupil tracking. It's another big area. Again, a lot of good work being done in the auto industry. So I'm driving my car and I'm looking this way, I'm texting. You know, VW already has pupil and eye sensing built into some of their cars. So they can either warn you or do other things or shake the steering wheel to let you know you're not doing what you're supposed to be doing. It's also necessary for VR goggles. You know, so if I have my goggles on and I'm looking to the left or the right, you know, in my peripheral vision, you're going to want to do different types of things for the image that you're looking at. You can also use it as a control input. Some of the companies that I think are really exciting, some of you might not, you know, they're doing lots of good stuff with miniaturization. Murata, CK, Bosch, Samsung, you know, these are companies who are making some of these key components that you're going to see pop up in these products. So if you work for one of those companies, you should be very excited. Don't say you're ESPP. Just know we got that. All right, connectivity, another big area. The problem with goggles is you got to plug them into something. And, you know, we're at the very front end of a lot of these technologies. Interoperability, consumer ease of use is really important. There's some good stuff that I saw being developed with interface standards for goggles for transferring video from the video source to the goggle and control back. It's being done by IEEE Visa. USB-C and the USB-C DP mode, if you don't know about those, keep an eye on that stuff. Mr. USB is somewhere right there. He'll be happy to tell you everything. hire this guy.
It's wonderful, except the connectors fall out of the socket.
Yeah.
You know, it's just.
That's CVMT, that's another night, so. So we have that, that's the IEEE materials and connector group, so. Go to their meeting, help them, yeah. The other thing, you know, is that there's a lot of stuff that's being piggybacked onto Wi-Fi. A lot of drones use Wi-Fi for the control. Well, it wasn't what Wi-Fi was intended for, so they're kind of manipulating it to get what they need because they need low-cost silicon, and that's what the low-cost silicon is today. There's a lot that's needed for asymmetrical rate data transfer. So that if you're wearing goggles, as an example, if you want to send a ton of data to the goggles, you want to send a little bit of data back. You know, here we are, I think we had an IEEE meeting 15, 20 years ago on 60 gigahertz data link for projectors. Okay, we're plugged into a cable, runs up through the ceiling, goes to the projector. For 20 years later, we still don't have this. It would be really, really nice not to have to run a cable to this projector. It's another example. I think goggles and drones are going to push this really hard. Let's see. All right, I'm almost done. This doesn't cover imaging, but I have to say this was probably the most exciting thing I saw at the show. And again, it's sitting on a table in a corner. Anybody know what this is? If you haven't read about it, this is the biggest freaking thing that I've seen in 5 years. It's spectroscopy. It's even hard for me to say. If you remember, everybody here took a chem lab in college, had a spectrometer. You know, in college it's like a big thing. You scrape some stuff and put it on a slide. Who knows what it does inside this giant machine? And then it tells you what the spectrum of the materials are. And then you look at that graph and you match it up to something else, and you go, oh, okay, that's table salt, or you know, that's a piece of bread. Well, that whole giant machine, which nowadays is this size, the company has reduced it down to this size, and they're putting it in a phone. All right? So now think about this. This thing is getting the spectrum of the composition of the object that you're looking at. It doesn't know what it is, but now that you're connected, it can shove that whole spectrum back to some server somewhere. The server goes, oh yeah, that matches up, it's a strawberry. For example, and the way it works, you know, is it sends a light beam, reflects a light beam off the surface of the material, it looks at the spectrum of the reflected light. And then from that, it can correlate that to what the object is. This is really, really big. There was a company who showed a demo of this where they could identify pills, drugs. So
I think you can tell if the strawberries are ripe or overripe, that kind of thing.
it's, like I said, this is, and all this is doing is it's taking a very well understood, fairly mature technology and reducing it in size. So they're not claiming to change the way physics works. They haven't invented some new way that electrical properties transfer information. It's the use, the miniaturization of an existing technology. And the other thing is, you know, this is, I found this on the internet, this is a laboratory machine, you know, that a chemical laboratory would use to analyze stuff. It's probably got, you know, NTSB traceable accuracy. Okay, if you sell this in a phone, and I'm at the grocery store, and I want to know if it's a guava or an onion, I probably don't care, you know, if it's like traceable to the National Bureau of Standards with its accuracy. I just need a rough approximation. So, again, can't say enough about this. Keep your eye on it. This is one of these moments that just like fell over with excitement.
What was the name of the phone company? The phone supplier. It's like obscure.
Or the application.
Yeah.
Chang'an.
Everybody knows them, right? I've never heard of them before. So this will be posted, you know, on the IEEE website. This is the company who developed this, and from what I've heard from the story, It started as a Kickstarter campaign. And then Analog Devices came in and said, no, this isn't Kickstarter stuff. We'll take it over and we'll help you, and we'll build silicon factories and whatnot to make it. So
How long before it shows up on the phone?
beats the heck out of me, but it's fantastic stuff. Anyway, I'm out of time. I covered my best 16,000 square feet per minute. Thank you for your time. And our next presenter.
So, yeah, exchange of
You want
mics.
the wireless, the
I will take-
non-battery pointer,
Yes, the wireless, the non-battery powered pointer
the perpetual.
and the speaking tube.
Okay, that's the one that
Oh,
works.
yeah. Oh,
And that one, I don't know who's on the other end.
this is probably for recording. I can't. One be above the others.
Tom, some like that. It's a real pocket.
Okay. I do have real pockets.
Oh, actually, it is continue.
They're still selling.
I said continue from the previous, so it's still
Okay.
recording, right?
Okay. I guess I'm on.
Did it stop? I didn't stop the previous one.